Mathematics 1, Lecture 8, Trigonometric Functions. A sine wave starts at 0, rises to the maximum, goes back through 0, through the minimum, and then back to 0 again. It has an amplitude, which is the distance from the maximum to 0, and it has a wavelength, which is the difference from one peak to the next peak, and it has a frequency, which is the number of complete curves in 1 unit of time. A cosine is very similar to a sine. The difference is it starts at the maximum, it drops through 0 to the minimum, then it rises through 0 back to another maximum. The amplitude is still the distance from the maximum to 0, and the wavelength is the distance between two peaks, and the frequency is the number of complete curves that you get in 1 unit of time. A combined wave is a combination of two or more sine and cosines. In this image we have a sine wave which is red, we have the cosine wave which is blue, and then we've got the combined wave which is purple. So when the sine is 0, the combined wave is the same as the cosine. When the cosine is 0, the combined wave is the same as the sine. The wavelength of the combined wave is the same as the wavelength of the sine and the cosines, but the amplitude is different. You can imagine the combined wave starting down here, and this distance is known as the phase angle. What we need to do now is to combine the sine and the cosine into one expression. From section 7.3 we know that sine theta plus phi is equal to sine theta cos phi plus cos theta sine phi. So we can write r sine theta plus phi is equal to r sine theta cos phi plus r cos theta sine phi. In this instance we know that y is equal to a sine theta plus b cos theta. Now if we look at the sine theta term here and the sine theta term here, we can say that a is equal to r cos phi. We have a cos theta here and a cos theta here, so we can say that b is equal to r sine phi. If we square both terms and add them together, we're going to get a squared plus b squared is equal to r squared cos squared phi plus r squared sine squared phi. If we take r squared outside a bracket, we've got r squared brackets cos squared phi plus sine squared phi, and we know that cos squared plus sine squared is equal to 1, which means that we can write that a squared plus b squared equals r squared, which means that r is equal to the square root of a squared plus b squared. Now if we look at these terms here, we've got sine phi and cos phi. So if we divide b by a, we're going to get r sine phi over r cos phi. The r's will cancel, and sine over cosine is tangent, which means that b over a is equal to tan phi. So therefore we can take the arctangent of both sides, so phi is equal to arctan of b over a. A and b can have any value from minus infinity to plus infinity. We have a problem with our calculators that they can't generally distinguish the difference between minus b over a or b over minus a. So let's just look at the 4 quadrants. In this first case we've got a is positive and b is positive. So let's just draw that. So a is positive and b is positive. So phi is going to be between 0 and pi over 2, or 0 and 90 if you prefer. When a is negative and b is positive, we get this situation. A is negative and b is positive. So there's our line, and the angle we're looking for is greater than pi over 2 and less than pi, or greater than 90 and less than 180. When a is negative and b is negative, a is negative and b is negative, now we're looking for an angle that is greater than pi and less than 3 pi over 2, or greater than 180 and less than 270. And finally, if a is positive and b is negative, a is positive and b is negative, we're now looking for an angle that is greater than 3 pi over 2 and less than 2 pi, or greater than 270 and less than 360. It's always good to do a quick sketch of A and B, just so you can find out what angle you're looking for and what angle your calculator is likely to give you. So let's do an example. Find the amplitude and phase of the combined wave y is equal to 4 sine theta plus 3 cos theta. So first of all we can calculate r, which is going to be the square root of 4 squared plus 3 squared. 4 squared is 16, 3 squared is 9, 3 plus 9 is 25, and the square root of 25 is 5. So we've got 4 is equal to r cos phi, and we've got 3 is equal to r sin phi. So that means phi is equal to the arctangent of 3 over 4. If we calculate that in radians, we get the value of 0.64 or 36 degrees. Let's just check that. We've got 4 in the x direction and 3 in the y direction. So the angle we're looking for is around 30 degrees, which agrees with the value that we've got. So that means we can now write 4 sine theta plus 3 cos theta is equal to 5 sine theta plus 0.64. A set of problems we often have to solve is a sine theta plus b cos theta is equal to a constant. To solve these, we transform a sine theta plus b cos theta into r sine theta plus phi, and we set that equal to c. So we have r sine theta plus phi is equal to c. Now if we divide both sides by r, we get sine theta plus phi is equal to c over r. Then we take arc sines of both sides, so we get theta plus phi is equal to arc sine c over r, which means that theta is now equal to arc sine c over r minus phi. If theta is negative, you would normally add 2 pi to the answer to get theta in the range 0 to 2 pi. This is the diagram of 4 sine theta plus 3 cos theta. The purple line is 4 sine theta plus 3 cos theta, and the green line is y is equal to 2. You can see that there are actually 2 solutions. To find the second solution, we subtract theta and phi from pi. And as before, if we get a negative number, we add 2 pi. So our first value is arc sine theta of c over r minus phi, and our second answer is pi minus arc sine theta of c over r minus phi. As an example, we'll solve 4 sine theta plus 3 cos theta is equal to 2. The red line is 4 sine theta, the blue line is 3 cos theta, the purple line is the combination, and the green line is y is equal to 2. From before we know that r is equal to the square root of 3 squared plus 4 squared, so that's equal to 5, and we know that phi is equal to 0.64 radians, which means that we can say that 5 sine theta plus 0.64 is equal to 2. We divide both sides by 5. We take the arc sine of the right hand side, which is 0.41. We subtract 0.64 from both sides, which gives us theta is equal to minus 0.23. It's negative, so we're going to add 2 pi to the answer, which gives us theta 1 is equal to 6.05 radians. And if we look at the diagram, that is this solution here. Now we need to find this solution. So what we're going to do is we're going to subtract arc sine 2 over 5 minus phi from pi, pi minus 0.41 minus 0.64, and that gives us 2.09 radians. As a sanity check, look at the diagram above. Pi over 2 is about 1.6. Pi is equal to 3.14, so this value here is around 2, which means that we can be confident that 2.09 is a correct value. We see we've got 2 pi here, which is about 6.3, so this value is about 6, which agrees with our calculated value. So we can be confident that our 2 values are correct. An additional thing we may wish to know is the location and magnitude of the maximum and minimum of the combined wave. So the amplitude is the square root of a squared plus b squared, but we have a constant which moves the curve up or down the y-axis. So that means the maximum is going to be the square root of a squared plus b squared plus the constant, and the minimum is going to be minus a squared plus b squared plus the constant. When the total angle, which is theta plus phi, is equal to pi over 2, the sign is a maximum. That means at the maximum, theta plus phi is equal to pi over 2, so theta max is equal to pi over 2 minus phi. A sine is at its minimum at 3 pi over 2, which means at the minimum theta plus phi is equal to 3 pi over 2, so theta min is equal to 3 pi over 2 minus phi. There's an infinite number of maxima and minima, and it's normal to give theta in the range 0 to 2 pi. As an example, let's find the magnitude and position of y is equal to 4 sine theta plus 3 cos theta plus 3. That's the shape of the curve, and from before we know that the amplitude is 5 and the phase angle is 0.64 radians, which means that the maximum is going to be 5 plus 3, which is equal to 8, and the minimum is going to be minus 5 plus 3, which is minus 2. So the maximum here is 8, and the minimum here is 2. So now what we want to know is where this position is. So from before we know that theta plus 0.64 is equal to pi over 2. So theta is equal to pi over 2 minus 0.64, which is 0.93 radians. Pi over 2 is equal to 1.5, so that is about 0.93 radians, so that looks okay. The minimum is minus 2, and it's somewhere between pi and 3 pi over 2. So theta plus 0.64 is equal to 3 pi over 2. So theta is equal to 3 pi over 2 minus 0.64, which is 4.07 radians.